This is the second half of the 2.4 Algebra 2 notes. So let's look here. It talks about finite differences. It says that when data have equally spaced inputs, that's talking about the x values. That means when the x values are equally spaced. So see, these x values are going by 1s, or they could be going by 2s or 5s. They just have to be equally spaced x values, which are the inputs. If they're equally spaced, you can look at the patterns of the outputs or the y values to determine what type of function can be used. So first differences are linear, second differences are quadratic, and then that pattern continues. Here's what they mean by differences. So when they talk about the differences, they are saying that we are going to subtract 4 minus 9. So we're going to take 4 minus 9. We're going to get negative 5. So that means from 9 to 4, it's going down 5. Now let's do it again. I'm going to do 1 minus 4. So I'm doing the right y value, subtracting, difference means subtraction, the y value right before it. So 1 minus 4 is negative 3. The right y value minus the one right before it, that's negative 1. 1 minus 0 is 1. 4 minus 1 is 3. 9 minus 4 is 5. Now, if we had done this, this was called first differences. That's what we did right here. It's where we subtract for the first time. So this is first differences. Had these all been the same, so the number we got out of it, had it all been the same, like 3 straight across, or 2, 2, 2, 2, 2, all the way across, that would have told us that the first differences are the same, and therefore it is a linear function. But because they weren't all the same, we're going to go ahead and we're going to do it again. And the second time we do it is going to be called second differences. So second differences is you take the differences you just found and you subtract those. Okay, so we're going to do negative 3 minus negative 5. All right, that's going to end up being 2. Negative 1 minus negative 3. Minus negative is plus, that also ends up being 2. 1 minus negative 1 is 2. 3 minus 1 is 2. And 5 minus 3 is 2. Okay, what we did here, we did what's called second differences. So we're subtracting the first differences. Okay, see how they are all the same. These are all the same. They're constant. So since they are constant, what that tells us is that this set of data is in a quadratic pattern. So therefore, a quadratic equation is going to be our best bet in terms of fitting an equation to the data. So when you are using this is when you are asked to look at the data and determine if it is linear or quadratic or something else. So what you do is you ensure that the inputs, the x values, are increasing or decreasing by the same amount. In this case, they're going up by 1s. So now we look at the y values, and we always do the second one, subtracting the one right before it. The third one, subtract the y value right before it. The fourth one, subtract the y value right before it. And you're looking, are they the same? Since they're not the same number on first differences, you move on. If they were the same number, it's linear. If you have to move on, if the second differences are the same number, it's quadratic. And this will apply further down past quadratic, but that's all we're going for today. Okay, so when you're doing real life data, they may make a quadratic pattern, like they may make a parabola when you graph the points, but it might not be exactly a parabola. So it may be closely quadratic. So when we do this, we have to use quadratic regression. So we're going to use this example right here. It says that NASA can create a weightless environment by flying a plane in parabolic paths. The table shows the heights, h of t, and feet of the plane t seconds after starting the flight path. So t is how many seconds after they've started the flight path. H of t, or h, is how high the plane is in feet. So after 20.8 seconds, the passengers begin to experience a weightless environment. It wants us to write a function that approximates the height and then evaluate it. So how we're going to write it in this case, if we graphed these would create a quadratic looking parabola. but they're not going to fit perfectly, so we can't just write it by hand. So we're going to go ahead and we're going to go to our calculator. Let me adjust mine so that it shows. All right. So I'm going to just get out of whatever I was in. I'm going to hit second quit. So now I want to go to my table and put these in. This is just like what we did in chapter 1. I'm going to hit stat. I'm going to hit enter on edit right here. So I want to edit the table. So I'm in here. If I had data, I'd clear it out. But since I don't, I'm going to put in my values, my X values into L1 and my Y values into L2. I'm going to go ahead and pause this so I can type them in. You put your X values into L1 and your Y values into L2, and then we'll be back here. Okay, so I have all my values in here. So now what I'm going to do is I'm going to hit stat. I want to go over to calc. So use your right arrow to go over to calc. And because I'm using a quadratic, earlier in chapter 1, we used linear regression. That was when we were creating a linear equation. But we want to use quadratic regression. So we want number 5. So you can hit 5, or you can go down to 5 and hit enter. Now my x's are in L1, my y's in L2. I'm going to go down to calculate. So here, it's giving me this equation. This is my a value is negative 11, so it's negative 11x squared. My b value is 700, so it's 700x. And my c value is 21,000, so it's 21,000. All right, so we're going to go ahead and write that down real quick. So it was negative 11x squared plus 700x, that was my b value. And then it was plus 21,000. Okay, so that's my equation. And then technically I should probably use t instead of the x's because they did ask me to use t. And then instead of y, I'm going to use h of t, which just means the height as a function of time, which is really what they told me right here. Okay, now it wants us to evaluate after 20.8 seconds. So that's time. So when we plug in 20.8, this just says I'm evaluating in 20.8 seconds. And I'm going to basically just type this into my calculator, just like this, to get the y value. So I'm going to do negative 11, use the parentheses exactly like I did. Up with roughly 30,800.96, but I feel like since they are approximating the height, it would be okay to say at 30,800 feet. This would be above the ground, is when the passengers started to experience weightlessness, a weightless environment. Okay. The table shows fuel efficiency of a vehicle at different speeds. Write a function that models the data. So we're going to go back in here. We're going to press stat. How I clear the list is I go up to where it's on L2 is the cursor. I hit clear, enter. Do the same thing on L1. Hit clear, enter. And I'm going to pause this video while I type in this data. X goes in L1, Y goes in L2. Okay, I've got all my data in, so I'm going to press stat. I'm going to go over to calc, and then I want the 5th one, quadratic regression. I go down to calculate. So we're just going to go ahead and round, so we're approximating here. My a value, let's just round everything to 2 decimal places. So negative 0.01. It's x squared. And then my b value was 1.37. X. And then my c value is negative 7.14. So there's my equation. And that is the model that will approximate the best gas mileage. So if we knew how many miles per hour we could drive in, it would approximate how many miles per gallon this vehicle was getting.